This video is a demonstration of how to graph a cosecant function. We begin with our basic curve, y equals 3 cosecant of x minus pi over 2 plus 1. We note that the parent for this function is cosecant. Cosecant is the reciprocal of the sine function. And we will begin by noting the characteristics for the corresponding sine function. If this was a sine function, the amplitude would be 3, the period would be 2 pi, the vertical translation would be 1 up, the horizontal translation would be pi over 2 to the right. As a cosecant function, it will have the same horizontal translation, the same vertical translation, and the same period. Cosecant is not a wave, therefore it does not have amplitude. But the 3 represents a vertical stretch by magnitude 3 away from the horizontal axis prior to translating up by 1 unit. Our next step is to graph the corresponding sine function using these characteristics. We will then build our cosecant graph off of that. Using the horizontal translation of pi over 2 to the right and the period of 2 pi, we're able to plot 2 points and some intermediate points using our amplitude of 3 as a support. Our vertical translation of 1 unit up allows us to move each of those points up 1 unit. Now, we have the correct location for the corresponding points on the sine function that corresponds to this cosecant function. We can now plot some additional points and use them to obtain the graph of the corresponding sine function. Now, recall that sine is the reciprocal of cosine. When sine is reciprocal of cosecant. When sine is equal to 0, the cosecant is undefined. Therefore, our previous x-intercept points, which have now all been translated up, are going to become vertical asymptotes on the cosecant graph. We draw those in. When sine is equal to 1, cosecant is equal to 1. So that point is shared by both curves. When sine is equal to negative 1, cosecant is also equal to negative 1. That point is also shared by both curves. When sine is equal to 1/2, cosecant is actually equal to 2. Therefore, that point does not correspond, but it does create a set of points that are above. When sine is equal to negative 1/2, cosecant is equal to negative 2. Again, that gives us a set of corresponding points that we can work with. Connecting these points and staying between the vertical asymptotes, we see that we get a series of U-shaped pieces to our graph. Note that these pieces do not cross the vertical asymptote. Our final step in the graph of the cosecant is to destroy or to get rid of or to erase the sine graph. What remains in blue is the graph of a corresponding cosecant function. Note that this function has a period of 2 pi. Note that it has been translated up 1 unit and that the horizontal translation of pi over 2 to the right appears in the graph. Note also that the vertical stretch of this graph is of magnitude 3. Thank you. A similar process can also be used to graph a secant function. In that case, we would use the graph of the corresponding cosine function and then draw in our vertical asymptotes and our curves above and below.